Hi everyone, welcome to the first ever LearnIt by Pintar chemistry video, and welcome to the first ever topic, which is Foundation 1 States of Matter. Now, before we move on to all the content and learning materials for this video, I think it's best that you guys get to know me first. So my name is Giovanna and I am an 11th grader from Sekolah Bugraya. I'm really passionate about science and I'm currently specifically focused towards chemistry, biology, and maths for my IB curriculum. My current hobby is that I'm binge watching C-dramas lately, and currently my watch is the First Frost, so you should check that out too. And the goal. So what I aim to achieve from everyone watching the chemistry videos is that I hope you understand the topic in the easiest way possible. So I hope that I'm able to explain all the content clearly and in detail so that you can understand the topic well. Okay, so here is the agenda for today's video. Is first I'll be discussing about the three states of matter, next the pressure and temperature in gases, thirdly the changing states of matter, fourth is diffusion, and lastly about solubility. Now let's start with the first topic, which is about the three states of matter, and the first one is the solids. So you can see from this diagram here, this dots are like really packed together in this diagram, and this is actually the structure of a solid. So they're really fixed in volume and shape, and they have a high density. Of course, that means that their atoms vibrate in fixed positions, and the particles are packed very close together in a regular arrangement. So due to this closely packed particles, and having a fixed volume and shape, especially that they're also only able to vibrate in fixed positions and therefore they can't change locations. So that's what results with the low energy of particles that is happening in solids. So next, besides solids, is that we have liquids. So say like solids, they have fixed volume, but the difference is that they adopt the shape of the container. So they're generally less dense than solids. This is an exception, however, for water. And they are more dense than gas. So you might be wondering, like, why is water perhaps more dense than solids? So in liquid water, the structure is far more fluid and they are slightly more dense than solid. And this is actually also due to the shape of the water molecules. So, for instance, the ice that has hydrogen bonds that creates this sort of hexagonal lattice structure, which results in a larger volume or mass. And that's what actually makes water more dense than ice. But so that I don't really go in detail about all those hydrogen bondings and hexagonal lattice, I'll save it for another video and hopefully I'm able to explain it later on in another LearnIt chemistry video. And next about liquids is that the particles move and slide past each other and the particles are close to each other, so they have a greater energy of particles in comparison to solids. And lastly, we have the gases. So as you can see, there's a difference now in the diagram. They do not have a fixed volume, but they still take up the shape of the container. Um, yes, they have low density, and of course, because of that, they can be compressed. Why? Because there is a lot of spaces between the particles, as you can see from the diagram here, which makes gases able to be compressed to a much smaller volume. And particles, they're far apart, they move randomly and quickly in all directions, but they have the highest energy out of solids, liquids, and gases. So next we'll be moving on to the topic of pressure and temperature in gases. So I want to ask you guys a question. You can pause this video. What do you see from this slide? Yes, there is a hot air balloon as well as bicycle pumper, or you can call it any other transport pumper. So this hot air balloon, as you can see, as the air inside a hot air balloon is heated up, it expands and the balloon gets bigger. And this is because the volume of a gas increases as temperature increases. So as you can see, this is a key important content or information that you should take note of, which is that volume of gases increases as temperature increases. Next, as you can see, there's this bicycle pumper or any transport pumper, you name it, but I'm going to call it a bicycle pump. So if you have a gas stored inside this container that is squeezed, the pressure increases as you decrease the volume. So as you compress the bicycle pump, you can see that the high pressure allows you to inflate a tire. So inflate the bicycle tire. You can feel the force of the high pressure if you put your finger on the end of the pump. You can try that. All right, so how does it relate with the kinetic theory? So pressure that a gas creates inside a closed container is produced by gaseous particles colliding. Colliding means basically hitting the inside walls of the container. So as the temperature increases, the particles in the gas move faster and they spread out more. And that's why they collide with the container of the walls more frequently. So if we take from the previous slide of the hot air balloon right here, you can see that, for example, if the container walls are flexible and stretchy, then they actually can get bigger and bigger, like how a hot air balloon is. So next, as you can see, I said that this results in a decreased volume. And you might wonder, why a decreased volume? Well, increasing the pressure means that there are the same number of particles, but in a smaller volume. And because the volume is decreased, they will actually hit the container walls more frequently. And that is why if the pressure is too high, sometimes you might notice that the container can result to an explosion. So the next topic is about changing states of matter. You can take a screenshot of this so that you can take note of it for maybe your future exams or future quizzes. This is a really important slide to take note of. So usually the questions would ask like, how did you convert solid to liquid? What do you call conversion from a liquid to gas? And this is the changing states of matter. So from solid to liquid, it is called melting. From liquid to solid, it's called freezing. And next, from liquid to gas, this is called evaporation. From gas to liquid, this is called condensation. And lastly, from solid to gas, this is called sublimation, and gas to solid is called deposition. So feel free to take a screenshot or as well as take note of this slideshow. And I'll be moving on to the next topic, which is about diffusion. So before I get into like the definition of diffusion, I want you to take a look at this two different diffusions that is happening. One is in gases and another one is in liquids. So this picture right here, it shows the bromine vapor as a gas, and it is actually diffusing. And as you can see previously, this red color is only the bottom of the tube, but now they have become spread it out and filled the entire test tube. So from here we can see that the particles, they move randomly, and there are larger gaps between particles, which makes these particles mix together. And how about for the diffusion in liquids? Well, as you can see, there's this picture right here. There's a solid cube that is dropped inside the beaker, in the beaker which is filled with water, and afterwards they diffused, and as you can see, there's now a purplish color changed. So the water and solid crystal particles, they move randomly and they slide over each other, and that makes it easily mixed together, as you can see from the picture. So from this picture, actually, what you can tell is that the diffusion is faster in gases than in liquids. And why is this? This is because gaseous particles, they have more energy and they move quicker than liquid particles, which is why I mentioned here that the diffusion in liquids is slower than diffusion in gases. So with that already covered, you might wonder what is diffusion, what's the definition of it? Well, you should take note that diffusion is particles moving from an area of high concentration to low concentration. So it occurs faster actually at higher temperature due to increased kinetic energy. And lastly, gases with lower relative molecular mass are lighter, so they travel faster and therefore also increases their rate of diffusion. And you might wonder, why is this? So gases with a lower relative molecular mass are lighter, which means that of course they travel faster and they travel further in the same amount of time. But this is also inversely correct if the gases have a higher relative molecular mass. So they travel slower and do not travel as far in the same amount of time. So here is a common question. Um, Which will have a faster rate of diffusion, ammonia or hydrogen chloride? And the answer is ammonia. So you might wonder, why is this so? From this picture, actually, you can see that the ammonia has a higher or distance and the HCl gas diffusion has a shorter distance. So you can see that the ammonium chloride from this picture, they are formed leaning more towards where HCl was initially located. And this is because of the relative molecular mass that I've mentioned in this previous slide right here. Is that because gases with lower relative molecular mass, they are lighter, so of course they travel faster. And in this case, ammonia is lighter than hydrogen chloride. So the molecular mass of ammonia is 17, while the molecular mass of hydrogen chloride is 36.5. And of course, that's why they travel fast, so ammonia travels faster and further. Essentially, if you're wondering, like, what is this molecular mass? Um, you count the molecular mass by working out how many atoms of each element there are in the chemical formula, and you add together the relative atomic mass values for all the atoms of each element present. You can find this in the periodic table. So for further explanation about relative molecular mass, how to calculate it, as well as about periodicity, it will be covered on the next video of LearnIt Chemistry, so stay tuned for that. This video will mostly cover just the basics, just the foundations of states of matter. So next is about solubility, and this will be the last topic of the video. So what is solubility? Well, it is the measurement of the ability of a substance, which usually is called as solute, to dissolve in a liquid, which is called a solvent. So if you're wondering what dissolve means, it's basically solute becoming a solution. So I've mentioned here that as temperature increases, solids become more soluble. Why is this? Well, as water molecules heat up, they vibrate more quickly and are better able to interact with and break apart the solute, which makes it easier to dissolve and therefore solids become more soluble. Now, what about for gases? Well, as pressure increases, gases become more soluble because an increase in pressure makes the gas molecules in the solute compress, and thus this creates more room for additional gas molecules, which is why later on they will have a high solubility rate. And I've also mentioned here that as temperature increases, gases become less soluble. So, as you all know, that increasing temperature, it results in increased kinetic energy, as I've mentioned. And gas molecules with greater kinetic energy, they move more rapidly, which breaks the intermolecular bonds between the gas solute and liquid solvent, so they have a decreased solubility. For more explanation about intermolecular bonds and all about overcoming intermolecular bonds, hopefully I will be explaining this in the next videos. And that is it for Foundation 1 States of Matter topic. And thank you all for watching this first chemistry video, and see you in the next Learn It chemistry video. If you have any questions, feel free to drop a comment in the YouTube video. Thank you everyone, and see you!